Good morning. So today we're going to talk about range and outliers. This is the notes that are going to go on page 122. These are going to be Cornell notes we're going to be writing. You can choose to do the column on the left for your questions, or you can choose to later on add a sentence summary question strip, or you can choose to use post-it notes later on to add it. I chose to use the whole space of the notes so that I have lots of room. The topic, once again, is range and outliers. Outliers is spelled O-U-T-L-I-E-R-S. The essential question is, how do we describe the spread of a data set? And this is the same essential question we've actually had for a couple of notes lately, because there's lots of different ways to describe the spread and to use the data that we have found. So just a little bit of review. We have been talking about mean, median, and mode. In my class first period, is there anyone who can explain what is the mean? James.
The mean is when you get a random set of numbers and you add them all up and divide them by how many numbers.
Okay, good. So James just said it's when you have a data set, you add up all the numbers, and then you divide by the amount of numbers that you have, and that is the mean. We also sometimes call that the average. What about the median? Cody?
The median is if you have an odd number, you find which number is in the middle, but if you have an even number, you add both numbers in the middle and the numbers in the middle, and then you divide it by 2.
Good. So once again, you put the data set in order from least to greatest. And then you go to the center. If it's odd, you're going to have a perfect center. If it's even, you're going to have 2 in the middle that you're going to have to find the mean of those 2 by adding them and dividing by 2. And what is the mode? Yes, Camden.
The mode is the number that is most repeated.
Correct. So the mode is the number that is repeated. Do we always have a mode? And can we sometimes, and they said no, and can we sometimes have more than one? Yes. Good. Okay, so that is our little bit of our review. The next thing I want you to do is I want you to write the term lower extremes. Lower extreme, or extremes, I said extremes, it should actually be extreme. I added an S in there that doesn't need to be in there. I'm going to get rid of that S. So not to confuse you, because there's only one. There, now it's just extreme. The lower extreme in a data set is also, sometimes we call it the minimum. It's the least data value in the data set. So if we have a set of numbers ranging from 1 to 22, 1 would be our lower extreme because it would be the smallest or the least number. And then with that understanding or with that knowledge, then what do you think the upper extreme would be? What do you think the upper extreme would be? Sierra?
The most data value in the data set?
It would be the greatest number in the data set. Good. And in that case, it would have been the number 22. And then we have the next concept that we have to understand is the lower and upper quartiles. Can you say quartiles? Quartiles. Think of that quar. When have you heard that prefix before? Quar. Lily?
Quarters.
Quarter. How many quarters do we have in a dollar?
4.
Good. Any other times you've heard quar? Yeah. Quadricycle. Quart, same kind of Q-U-A. Good. A quadricycle, how many wheels does that have? 4. So with that understanding of that qua or that quar prefix, how many times do you think we're going to divide our data set? Into 4. Okay. So let's see how this works. It is the lower and upper quartiles are what we're going to do is we're going to find the median of the lower and the upper halves of the data set. So we're going to take our data set, we're going to find the upper extreme, the lower extreme, we have the median that's straight in the middle, and then from each side of the median to the upper extreme and the median to the lower extreme, you're going to find the middle of each of those, which will divide our data set into 4 pieces. And then we have the interquartile range. Now, I haven't talked to you about this term yet, so I want to make sure that it's very clear to you. I'm going to skip this, and I'm going to let's leave 3 lines. So 1, 2, 3. And I'm going to go here, and I'm going to write range. Because you can't really understand the interquartile range until you understand the range. And the range is the spread of the data set. And you find this by taking the greatest number let me move that up so you can actually see it. The greatest number and subtracting the least. So if we take our numbers from 1 to 20, to figure out the range, you would take the biggest number, which would be 20, and you'd subtract the 1, and you'd say, okay, there's 19. 19 would be the range of that data set. So with that being said, now let's go back to interquartile range. So we can fill in that piece now. Interquartile range is the difference between the upper and lower quartiles. And you're going to see how this plays in when we actually draw an example. Okay, so here's what we're going to do. I'm going to write a list of numbers. I'd like you to copy these numbers onto your paper. We're going to start with, and you're going to try to spread these out like I am. So I'm going to actually start with the middle and work my way up and back for the middle. So my median is going to be 70. Then I'm going to have 60. I'm going to have 60. I'm going to have 42, and I'm going to have 40. Then going the other way from the median, I'm going to have 76, 78, 78, and 150. Now, looking at this, if I start off, I can find the mean by adding them all up and dividing by the numbers I have. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, which tells me I'm going to have a perfect median. So if I work my way back in, I get to where 70 is my median. My lower extreme is here. the smallest number. My upper extreme is here. Now, this brings me to another term that we oftentimes use when we're talking about data set. When you have data sets, you'll end up with these numbers that are all kind of clustered together. So if you look at these numbers, 40, 42, 60, 60, 70, 76, 78, 78, and then you end up with this 150. And I want you to think about that if that was on a number line. Wouldn't all of those other numbers be kind of clustered closely together within about 40 points? And then you would have 150, and it would be shooting out way in the distance, right? It kind of makes it an unusual number. It's kind of an odd thing to be a part of this set because it doesn't seem to make sense with the pattern. If that happens, we call this number, this one that's way out in Nowheresville, we call that the outlier. And for lack of a better way of explaining it, I call the outlier the freak number. It's the number where when you have a bunch of numbers in a data set that you're like, what in the world? Where did that freaky number come from? It doesn't make sense. And so we kick it out oftentimes when we're putting data onto a data table because it would mess up our data. And sometimes data is like that where you just get some random weird number, and that happens. So oftentimes that outlier is thrown out because it will change your mean, it will change all of your data if you don't do that. So if you end up with a number that's kind of, it doesn't make sense in the scheme of the data, all your numbers kind of go together in a sequential flow and they're within a certain area, and then you have one that's way out in nowhere, we call that, once again, the outlier. So you just need to understand that term. Now, looking at this data set, we have these numbers that go from the median to the lower extreme. And we call these numbers in here the lower quartile. And then these numbers that go from the median up to the upper extreme, we call this the upper quartile. Yes?
What's quartile mean?
We just talked about that in our notes. We're dividing it into 4 pieces. So we would then find the mean of each of these, and then you'll end up with 4 pieces. So the quartile just means that it's the division between the mean or the median and either the upper or lower extreme. Okay, so now what we're going to do is we're going to find the interquartile, we're going to find the mean, I keep saying the median of each of the quartiles. I apologize. To do that, you're going to go into this section here, and you're going to work your way in, not going to the median, so you're not going to include the median, but you're going to jump. So here's 40 to 42, 60 to 60, and then I end up with these numbers in the middle here, right? Just like we found the median on a larger piece of data, we would then say, okay, 42 plus 60 equals 102. And then we're going to divide by 2. And so our lower quartile, the middle of that section, is going to end up being 51. Thank you. There we go. So the middle in here is going to be 51. That's the middle of our lower quartile. Then we're going to have to find the middle or the median of our upper quartile. Once again, we're going to go 76 to 78, 150 to 78, and we end up with 78 plus 78, which ends up being 156. We divide that by 2, and we, shockingly enough, get 78. So our median here is 78. Now, let's figure out the range of this whole data spread. The range in this case would be, we would take the largest number, which is in this case 150. We would subtract the smallest number, which is 40. And class, what would our range be?
110.
110. Good. Now let's figure out the interquartile range. Now the interquartile range is going to be, let's look at the median of one quartile and the median of the other quartile, and let's figure out that distance between just those medians. So you're going to look at the median of the upper quartile is what? 78. What is the median of the lower quartile? 51. Good. So we, just like we did on the regular range, this time using just the medians of the two quartiles, we are going to find that the range between there is going to be 27. The space between here and here is 27 numbers. Okay, I'm going to move now to page 121. On 121, I want you to write box and whiskers plot. Now there's different ways that we demonstrate data. We can have line graphs, histograms, dot plots, bar graphs. We can have all kinds of different ways. This is another way of representing data, specifically representing quartile ranges, interquartile ranges, medians, and such. So the box and whiskers plot is a data display that divides a data set and it divides that data set into 4 parts. And those 4 parts that it does are the lower and upper extremes, and the lower and upper quartiles. Okay, so here's an example. And we're just going to go right into action on doing an actual example because that's really the best way to understand box and whiskers plots. I can explain it until I'm blue in the face, but until you actually use the numbers and start to do it yourself, it doesn't make much sense. So, we're going to, I'm going to change pen colors. You don't have to, I'm just doing it because I'm getting bored with the red. Here is your example. This data set represents the winning and losing teams I'm going to say team scores in the past 6 Super Bowls. And actually, I found this question a couple years ago, so this isn't the most recent Super Bowl, just so you know. So we're looking at, and this is specifically how much they won and lost by. So the question itself is probably not as it doesn't make as much sense as I'd like. To clarify, it's taking what the winning team got and subtracting what the losing team got and the difference between their scores. Does that make more sense? So I'm going to put these into order for you already. So we have 1 point, 7 points, 14 points, and actually I need to make that 14.5. There was a point in there. So 14.5. So 1, 7, 14.5, 21.5, 36, and 45. So 1, 2, 3, 4, 5, 6. Okay, the first thing we want to do is we're going to find the median. So we're going to find the median. To find the median, we go to the middle. If it's even, which it is, we're going to have to find the mean of the two in the middle. So working our way in, 1, 2, I end up with 14.5 plus 21.5. When I add those together, this is going to be 1. Actually, I've got 1 plus 2 is 3, 35, 36. So I end up with 36, but I need to divide that by 2. So I get that my median is going to be 18. So it's going to kind of fall in here. Alright, so now what I'm going to do is I'm going to create a line graph. To create this line graph, I am going to let's draw arrows, and I'm actually going to start with, here's 0, and I'm going to count by hopefully 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44. Oh, I made it. Ish. I made it very close. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44. I'm very tight in there. But I think it'll work. Okay, so first thing I'm going to do is I'm going to mark where my median's at. My median, what was it again, guys? 18. So it's right here. This is my median at 18. Next, I'm going to find my lower extreme. So what is the lower extreme? 1. Good, which is right here. So I located median, lower, and upper extremes. So this is the second thing you do. What is my upper extreme, class? 45, which is right here on my arrow. Okay, now the next thing that we are going to do is we're going to find the median of each quartile. To find the median of each quartile, what I'm going to do is I'm going to look up here at my numbers, okay? And actually I can even go up to my data set. And I'm looking at between 1 and 14.5. So if on the lower extreme I have 1, I have 7, I have 14.5 because I'm not counting my median. I don't want to count my median. This is my lower. So this is my lower. Here's my upper. In my upper I have 21.5, 36, and I have 45. Well, luckily for me, I have a center of each of those. So that becomes the median of both the lower and upper quartiles. So I'm going to then put my dots for those two. There's 7, and on this side I have 36. Okay. Now, this from here to here is the interquartile range. Now, that's all the data that we have to place. Do you want to see why they call this a box and whiskers plot? Because right now it just looks like a line graph with some dots on it. The reason they call this a box and whiskers plot is because I'm going to draw a line up from the median, like so. Then I'm going to draw a line from the median of the lower quartile and the median of the upper quartile, like so. Now I'm going to connect those 3 sections with a box. Hence why we call it a box. But wait, there's whiskers. So here's why we call it a box and whiskers. Here's the box that connects our interquartile range. Here is a whisker that goes out to your extreme, and the other whisker goes out to your lower extreme. Here's your box, a whisker, and a whisker. And just for fun, whenever I do my first box and whisker plot, I make it into a cat. Because why not? It's called a box and whiskers plot. So this is how you can use this data. Remember that the center line is your median of the whole data spread. You find the median of between the lower extreme and the median, which is your quartile range, your quartile. Then you find the median between the upper and the median, which is here. That creates this interquartile range that you box. And then you have your whiskers or your lines that go out to those upper and lower extremes. And this is one way to show the spread of data. Thank you.